Hi, I am Raghavan, Chemistry Faculty from ALPHORES College. So I invite you all of you for the ALPHORES Chemistry e-learning program classes. So the session 35, okay. So in the last session we explained that is the fundamental principles of electron configurations like Aufbau principle, Hund's principle, that is Hund's rule of maximum multiplicity, and Pauli's exclusion principle is completed. And in addition to these, we completed the magnetic properties of the elements also we completed, that is like diamagnetic properties, paramagnetic and ferromagnetic. Okay, so what is a paramagnetic property? How we can calculate that? The magnetic moment of paramagnetic substances can be calculated using the expression. So that equation I am rewinding that. So that is under root magnetic moment is equals to under root n into n plus 2 Bohr magnetons, that expressed in Bohr magneton units, where n is equals to, this n represents the number of unpaired electrons. Okay, suppose if that atom or ion contains 2 unpaired electrons, suppose if it is 2 unpaired electrons, that is 2 into 2 plus 2, that is 2 plus 2 4, 4 to the 8, that is equals to root 8 Bohr magneton units. Okay, like that we can identify, we can calculate the magnetic moment of the paramagnetic species. Okay, so that also we completed. So all these concepts we completed. That means atomic structure is completed. Okay, atomic structure is completed. Today we are going to discuss about the revision of some important concepts, like for example, that is objective oriented questions for the coming examinations. Okay, so how we can discuss the objective oriented questions from the past topics, how we can revise it, let us see. Okay, today is the examination point of view revision questions, examination point of view revision, examination point of view the revision. Okay, now the revision for the examination point of view. Yes, revision for examination point of view. Okay, the first question, how we can revise it? See, which among the following set of quantum numbers, represents highest energy? Which among the following set of quantum numbers represents highest energy? Okay, options are like this. First option, so the question is, which of the following set of quantum numbers represents highest energy? Okay, so the options, first one, that is n, l, m and s values, that is principal quantum number value, azimuthal quantum number, magnetic quantum number and spin quantum number values. So the values are like this. Okay, that is, say for example, it is 3, it is 1, it is 0, it is plus half. So that is first option. Second option, 3, 0, 0 plus half. And third option, 3, 2, 1 plus half. Fourth option, 3, 1 plus half. Identify which among the following, that is which of the following set of quantum numbers represents highest energy. So how we can identify the energy of the atomic orbitals? Energies of atomic orbitals based on n plus l values, Okay, so greater the n plus l value is the higher energy. Okay, if n plus l value is greater, this is higher. If n plus L value is higher, that is n plus L value is higher, so therefore it is high energy orbitals. Okay, that point we should remember that. So now identify n plus L value, you no need to consider them because the possible L value, that is m values are all possible. So all the set of quantum number values are possible. So now in which case we have greater n plus L values. N plus L value only we have to consider. So n plus L value is equals to, this is 4. Here n plus L value that is equals to 3. Here n plus L value is 5. Here n plus L value is 4. Yes, the orbital which n plus L value is higher is greater energy. So that is higher energy. That is nothing but it is 3D orbital. So higher the n plus L value, higher will be the energy. So third option will be the answer for this. Okay, the concept you have to remember. So the energy of the atomic orbitals depends upon n plus L value. Okay. Higher the n plus L value, greater will be the energy of the orbital. That is the concept. Okay, that is how to identify the energies of atomic orbitals. That is done. Okay, so that is completed. That is completed. Now let us see, is there any other possible question we can prepare from this? Yes, let us work out. Yes, which among the following shows lesser minimum n plus, there is minimum energy. Which among the following set of quantum numbers, represents minimum energy orbital? Higher energy orbital we identified, it is because higher n plus L value is higher energy. That is over. Okay, so for this, third option is the right answer. Now next question we can prepare from the same options. Which among the following represents least energy or minimum energy orbitals? Yes, that means what? Lesser n plus L value, higher n plus L value is higher energy, lesser n plus L value is lesser energy. Identify that. Lesser n plus L value, so it is 4, it is 3, it is 5, it is 4. So lesser n plus L value is 3, that is 3s orbital, it is 3s orbital, it is 3p, 3s, 3p, 3p, 3d. So 3s orbital having lesser n plus L value, that is the least energy, minimum energy. Okay, like that the possible questions from this. So based on the 4 set of quantum numbers, we can expect the higher energy as well as the lowest energy, that is minimum energy orbitals. You got my point? That is one type of question we have to understand. How to analyze the question based on the given data, then how to answer the question. Okay, that is one concept is understood. Okay, that is higher the n plus L value, here I will write. So if n plus L value is greater, if n plus L value is greater, then energy is higher. Okay, if n plus L value is lesser, energy of the orbital will be minimum. Okay, like that we have to remember that concept. Okay, let us take the next one, next concept for the weekend revision. Okay, next concept. Yes, which among the following ion is more stable? Which among the following ion is more stable? Yes, which among the following is more stable? Is more stable? Yes, is more stable. How to identify that more stable ion? What are the options? Let us identify. First option, let us say it is Fe plus 1. Second option, Fe plus 2. Third option, Fe plus 3. Fourth option, Fe plus 4. Okay, Fe plus, like that we have 4 options. So which among the following is more stable? So how we can explain that stability of ions or atoms? It is based on the Hund's rule we explained. Okay, it is based on the Hund's rule. So according to the significance of the Hund's rule, we know that half-filled orbitals, the species containing half-filled orbitals or completely filled orbitals is more stable. Okay, that concept we know that. So based on the same concept we have to explain that. So let us see. So how many of these species having completely filled orbitals or half filled orbitals? Iron atomic number is 26. Okay, iron atomic number is 26. First I will write normal configuration. Argon. Okay, argon 4s2 3d6. That is the normal configuration. Plus 1 means it lost one electron from the 4s orbital. So it is 4s1. How many unpaired electrons are there in this? So s orbital. So not considered for the Hund's rule. So d orbitals. So d6. d6 means how we can identify that? d6. All the 5 d orbitals are like this. 1, 2, 3, 5. 5 d orbitals. d6 is there. d6. That is 1, 2, 3, 4, 5, 6. How many unpaired electrons? 4 unpaired electrons. That means Fe plus 1 ion is having 4 unpaired electrons. It is not exactly half filled d orbitals. Okay. So then coming to this one. So Fe plus 2. Fe plus 2 means what? So iron atomic number is, that is 26. So normal configuration of iron 4s2 3d6 plus 2 means it has lost 4s electrons. 3d6. 3d6 means this is the configuration 3d6. Okay, this 3d6 has, the 3d6 has 4 electrons, that is 4 unpaired electrons. 3d6 has 4 unpaired electrons, that is 3d6, that means 4 unpaired electrons. Okay, Fe plus 3 normal configuration 4s2 3d6. So 4s2 3d6, it loses 2 electrons from the 4s orbital first, then 1 electron from the 3d orbital, then it will get 5 unpaired electrons. Yes, 3d5. It has got 5 unpaired d electrons. That means all the d orbitals are exactly half filled. Yes, this is the right answer for us because half filled d orbital is present in this. Let us take one more. That is Fe plus 4. Fe plus 4 means what? So this ion also lost 1 electron from the d orbital. 1 electron from the d orbital. That means it will get, after losing the electron, it will get only 3d4. So 3d4. That means it has got 4 unpaired electrons only. Okay. So among the given options, half filled d orbitals are present in Fe plus 3 ion. Therefore, according to the significance of the Hund's rule, Fe plus 3 is more stable than the other species given. Okay. That is a concept we have to understand. Okay. Next, let us exercise one more. Yes. That is, the question is like this. The following set of ions, possess the same magnetic moment. The following set of ions, or you can say the following pair of ions, possess the same magnetic moment. Okay. The following pair of ions possess the same magnetic moment. That is the question. Now the options let us observe. First option, Fe plus 2, Fe plus 3. That is first option. Second option, Fe plus 2, Mn plus 2. Okay. Third option, Fe plus 3, Mn plus 2. Coming to the fourth option, Fe plus 3 and nickel plus 2. These are the 4 options are given. You have to identify the species which contain same number. See, magnetic moment means what? So magnetic moment, once again, let me explain that formula for magnetic moment, how to calculate magnetic moment. Magnetic moment of paramagnetic substances can be calculated by using the expression like this: under root n into n plus 2, where n is equals to number of unpaired electrons. Okay, so number of unpaired electrons. If the two species having the same number of unpaired electrons, they shows similar magnetic moment. That is only the solution for us. Okay, now identify which pair has the same number of d electrons. Which pair having same number of d electrons? Fe plus 2 ion having Fe plus 2. What is the configuration of Fe plus 2? Iron atomic number 26 after losing 2 electrons from the 4s orbital. Okay, so it has got 3d6. It has got 3d6. 3d6 means how many unpaired electrons are there? 4 unpaired electrons. Okay, you should remember that point. Okay, next Fe plus 3. Just now we explained that Fe plus 3, that means it has got 3d5. Okay, let us write with different ink, that is different chalk. Okay, that is 3d5, 3d6. Here it is 3d6, here it is 3d5. Okay, so next Fe plus 2, again we already know that it is 3d6, that is 4 unpaired electrons. Mn plus 2, Mn manganese atomic number 25, argon 4s2 3d5. Okay, out of argon 4s2 3d5, it is Mn plus 2, that means it loses 4s electrons first, so therefore it has 3d5. So this electron, this atom, this ion is having 3d5, that means 5 unpaired d electrons. Okay, now here only we got that, yes, these two species having the same number of electrons. Okay, that is Fe plus 3 having 3d5, that is 5 electrons and 5, that is 5 unpaired electrons. Okay, it is plus 2, it is plus 3. Okay, now 3d5, Mn plus 2 also having 3d5. Yes, this is our option. So third option, which contain the same number of unpaired d electrons, therefore they possess the same magnetic moment. You got my point? They possess the same magnetic moment. What about the fourth option? So this is, we know that 3d5. And what about nickel plus 2? Nickel atomic number is 28. So the configuration becomes argon 4s2 3d8. 3d8 means 5d orbitals, 3d8 configuration, 1, 2, 3, 5, 3d8 configuration. So 3d8, 1, 2, 3, 4, 5, 6, 7, 8. So how many unpaired electrons are there? d2. Okay, 3d8 means it has only 2 unpaired electrons. That point you should remember. Okay, like this we can identify. So which option has the same number of unpaired d electrons? Third option is having the same number of unpaired d electrons. Therefore, third option, since they contain same number of unpaired d electrons, they shows the same magnetic moment. Okay, that is the important point we have to understand. Okay, first, after getting the question, how to analyze, so that is you have to write the required electron configuration. Okay, and then we can identify the answer. It is very, very important question for your objective examination point of view. Yes. Okay, this is one type of question we can make out. Okay, next we have to prepare another question. Yes. Okay. So what is the question? How we can prepare it? Yes. How many electrons, how many unpaired electrons are present? See, in which of the following? Question is like this. Let us write question first. In which of the following? In which of the following? Which of the following? In which of the following? In which of the following has maximum number of electrons, has maximum number of unpaired electrons? In which of the following has the number of unpaired electrons, same number of unpaired electrons, which of the following has same number of unpaired electrons, which of the following has same number of unpaired electrons as those present in vanadium plus 3 ion. Got it? That is a complete question. So which of the following has the same number of unpaired electrons as those present in vanadium plus 3 ion? First you should know how many unpaired electrons are present in vanadium plus 3 ion. Okay, vanadium plus 3 ion. Okay, that you have to remember. Now the options like this. Options, say it is right, nickel plus 2. Let us give nickel plus 2. Second option is Fe plus 2. Third option is Zn plus 2. Fourth option is Mn plus 2. Yes, these are the options. So question once again, which of the following has the same number of unpaired electrons as those present in vanadium plus 3 ion? Let us see first what is vanadium plus 3 and how many electrons are present. Solution for this, explanation of that solution. Vanadium atomic number is 23, scandium, titanium, vanadium 23. So the normal configuration becomes like this: argon, that is 3d, argon 4s2 3d 3, argon 4s2 3d3. So that I am writing like valence shell. So 3d3 4s2. Okay, according to the above principle we have to write 4s2 3d3. Now I am writing outermost shell like this. Okay, so that you can understand outermost valence shell easily. So that is 18, 20, 23 balanced. So now 4s2 3d3, it is vanadium plus 3. Vanadium plus 3 means it can lose first outermost 2 electrons. That means 4s electrons are gone. Okay, then after losing 2 electrons from the 4s orbital, one more electron is losing from 3d orbital. So if that is vanadium plus 3 is configuration is becomes argon 3d2. Argon 3d2. So d orbitals are 5. Out of 5, only 2 d orbitals are occupying with single electrons. That means how many unpaired electrons are there? Only 2 unpaired electrons in this. 2 unpaired electrons. Vanadium plus 3 has 2 unpaired electrons. Now you have to identify which among the following option is having 2 unpaired d electrons. That is the question. Nickel plus 2. Nickel plus 2. Nickel atomic number is 28. Okay, nickel atomic number is 28. Nickel 28. So argon 4s2 3d 8. So nickel plus 2 means it loses outermost 2 electrons. That means 4s electrons are gone. So 4s 0, 3d8. 3d8 means all the 5d orbitals 1, 2, 3, 5. 5d orbitals. 3d8 1, 2, 3, 4, 5, 6, 7, 8. It has got 2 unpaired electrons. Yes. So 3d8 has 2 unpaired electrons. Yes, this will be the right answer for us. Let us work out on the other options also. So Fe plus 2. Fe plus 2, that is iron atomic number is 26. Iron atomic number is 26. So therefore, okay, that is argon 4s2 3d6. That is the configuration. It is Fe plus 2. Plus 2 means it loses outermost 2 electrons. That is 4s electrons are gone. That means it becomes 4s0. 3d6. 3d6 means how many electrons we can see. This is the 3d6 configuration. This is 3d6 configuration. How many electrons, unpaired electrons are there? Yes, sir. It is 4 unpaired electrons are there. So it is 3d6. 3d6. It has got 4 unpaired electrons. It has 4 unpaired electrons. Okay. So vanadium plus 3 having 2 unpaired electrons. Which of the following option contains the same 2 unpaired electrons? That is first option. Already we have done. So we are explaining, counter checking the other options. Zinc atomic number. Zinc atomic number. Zn atomic number is 30. So 30 electron configuration argon. Yes. That is 4s2 3d10. 4s2 3d10. Zn plus 2 is mentioned. That means the 4s electrons are gone. So 4s is 0. So 3d10. 3d10 means all the d orbitals filled with 10 electrons. That is complete orbitals are filled with 10 electrons. That is 0 unpaired electrons left. 0 unpaired electrons. Next, Mn plus 2. Mn plus 2. Already we worked on this. Mn plus 2. Okay. Manganese atomic number is 25. The configuration of manganese is argon. Okay. 25. Argon. So argon 4s2 3d5. 4s2 3d5, and since it is a plus 2 means it loses outermost 2 electrons easily. So therefore 4s0 3d5. 4s0 3d5 means all the d orbitals contain 1 electron each, like this. Yes, that means 3d5. It has got 3d5. 3d5. That means it has maximum number of unpaired electrons, 5 unpaired electrons. Okay. So answer for the question is nickel plus 2 contains the same number of unpaired electrons as those present in vanadium plus 3 ion. Like that question is also important for the objective examination point of view. Okay. Like next one, let us take the another concept. Yes. What is the concept? How we can proceed with the concept? What is the next question we can prepare? Yes, that is if Pauli's principle is not known to us, the electron configuration of lithium atom will be the question is if Aufbau principle is not known to us, then the electron configuration of lithium atom will be okay. Then the options we can give like this. What is the first option? Say for example, that is 1s2 2s1. Okay. Second option 1s1 2s2. Third option will be, we can say 1s3. Fourth option is, say it is none of this. Okay. If Aufbau principle is not known to us, if Pauli's principle, so it is not Aufbau principle, it is Pauli's principle. If Pauli's principle is not known to us, then the electron configuration of lithium atom will be, that means what is the Pauli's principle says that an orbital can accommodate maximum of 2 electrons. Okay, because no 2 electrons can have all the 4 quantum number values identical, we know that. That means what? So the 2 electrons belongs to the same orbital can have the same principal quantum number, azimuthal quantum number and magnetic quantum number values, but they differ in spin quantum number values. That means what? How many spin quantum number values are allowed in the orbital? One is plus of, the other one is minus of. That means 2 spin quantum number values are allowed. Indicates what? So orbital can accommodate only 2 electrons, clockwise and anti-clockwise electron. Yes, that means Pauli's principle indicates that an orbital can accommodate maximum of only 2 electrons. Okay, so if Pauli's principle is not known, that is 2 electrons in the orbital, constraint is not present, then all the electrons goes into the same subshell. That means we can expect that third option is the right answer, because all the 3 electrons goes into the same s orbital, because orbital can accommodate 2 electrons, that constraint is not present in this. We don't know that Pauli's principle is not present. If Pauli's principle is not known, that is the 2 electrons in the orbital restriction is not present. So then all the 3 electrons will join in the same subshell. That is 1s3. Okay, what about this one? It is according to the Pauli's principle. S orbital is completely filled with 2 electrons, then the next electron goes into s orbital. Okay, so it is against, it is none of this. So the answer will be 1s3. If Pauli's principle is not known to us, then electron configuration of lithium atom will be like this. Okay, like that. Then that is one type of concept we can understand, we can identify. Next. Next question also we can explain like this. In which of the following has maximum number of unpaired d electrons? Which of the following has maximum number of unpaired d electrons? Maximum number of unpaired d electrons. Okay, so which of the following has maximum number of unpaired d electrons? Maximum number of unpaired d electrons. Okay, maximum number of unpaired d electrons. Maximum number of unpaired d electrons. Options. Let us see the options. Unpaired d electrons. Okay, first option, scandium plus 3. Second option, zinc plus 2. Third option, copper plus 1. Fourth option, copper plus 2. Maximum number of unpaired d electrons. Maximum number of unpaired d electrons. So first let us work out scandium plus 3. Scandium atomic number 21. So the scandium configuration becomes argon 3d 1 4s2. Okay, now this is zinc, argon. I am writing the configuration of the atom. Okay, so argon, it is 3d10, 4s2 3d10 plus 3 means it will lose. I will write the ion configuration. So therefore, so it is plus 3 means it can lose first 2 electrons from the 4s orbital and 1 electron from the 3d orbital. Okay, so 3d 0, 4s 0. Okay, argon 3d10, and copper plus 1, argon 3d10, argon 3d10, because plus 1 means outermost electrons are gone, 4s electron is gone. Next, copper plus 2, so argon 3d9, argon 3d9. Yes, here there is no unpaired electron. Here all the d orbitals are completely filled with 10 electrons. In this case all the d orbitals completely filled with 10 electrons, and copper plus 2 has 3d9. 3d9 means how many electrons are present in this? 1, 2, 3, 5. Okay, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Yes, it has got one unpaired electron. So therefore this will be the answer for us. So copper plus 2 has one unpaired electron. Okay, so this is the part of the revision for the weekend examination practice. Okay.